Alright guys, so this is the second application for my sum and difference properties. So what we have here is it gives us some information about the sine of A and the tangent of B. What we're going to do is we're going to use this information to draw some pictures and use those pictures to find the sine of A minus B. What we cannot do here, which is what a lot of people try and do, is they try and just say that this is the sine of 1/2 minus 3/4. Okay, I can't do that, and the reason for I can't do that is because A is not 1/2. What you have to understand is that this is telling me that the sine of A is 1/2. A is an angle, and I actually don't know what that angle is. But in order to solve this question, I actually don't need to find that angle. But I am going to draw a picture of it. So I'm going to draw that angle A. It tells me that the sine of A is a positive 1/2, and the cosine of A is greater than 0. Numbers that are greater than 0 are positive. So this means that A has a positive sine and a positive cosine, which means it has to go in quadrant 1. So after I draw my triangle, I'm just going to fill in my values. I've got an opposite of 1 and a hypotenuse of 2. So Pythagorean theorem, my missing side is √3. So now I'm going to draw my second triangle. So my second triangle has a tangent that's positive, but a sine that is less than 0. So that means that my sine is negative. Tangent is positive in quadrants 1 and quadrant 3. However, sine is only negative out of those quadrants in quadrant 3. So this one is going to be drawn in quadrant 3. So I'm going to draw my triangle. This is B. I'm going to fill in my opposite over my adjacent. Those both have to be negative because of where it's located, but that still would give me a positive 3/4 when I find it. Then Pythagorean theorem for my missing side, and I get 5. So what we're going to do is we're just going to take that information and use it to find this exact value. So if I look at my formula chart, the sine of A minus B can be expanded to sine A times cosine B minus cosine A times sine B. And I'm just going to start to fill in those values. The sine of A, the entire sine of A is getting replaced with 1/2. The cosine of B, not just the letter B, but the entire cosine of B I can also replace. If I look at my B triangle, my cosine is adjacent over hypotenuse, which is -4/5. So that gets replaced with -4/5. Then I'm going to look at cosine of A. The cosine of A, I look at that A triangle, I do adjacent over hypotenuse, which is √3/2. And then finally I'm going to do the sine of B. And the sine of B is going to be my opposite over hypotenuse on the B triangle, which is -3/5. And then at this point, it's just some math with some fractions. So I am multiplying and then I am subtracting. So I'm going to do -4/1, or -4 times 1 over 10 minus -3√3/10. And then I can combine these together into -4 plus 3√3/10. And I cannot divide 2 out of this one. Even though 4 and 10 are both divisible by 2, the 3 is not, so I'm going to have to leave it here. Alright, so there's one other application of these that we can use, and that is going to be, sorry, I'm having trouble with my slide, that's going to be to find some exact values we haven't done yet. So I have been able to figure out the exact values for 0, 30, 45, 60, and 90, and those equivalent reference angles. But something like 15 I haven't been able to find until now. But now I can, because I know that 15 degrees is the same thing as 45 minus 30. And I know the exact values of the sine of 45 degrees and the sine and cosine of 30 degrees. So I'm going to use this expression, and I'm going to expand this using my properties. So this expands into the sine of A, which is 45, times the cosine of B, which is 30, minus the cosine of A, times the sine of B. And then at this point, I just need to find those exact values, which I've done before. The sine of 45 is 1/√2. The cosine of 30 is √3/2. Cosine of 45 is 1/√2. And the sine of 30 Alright, so at this point then again I'm just going to do that same math. So this becomes √3 minus 1/2 √2. Now my other two actually are going to be a little bit simpler. So in order to find the cosecant of 15 degrees, I could work through this entire thing again, or I could realize that the cosecant of 15 degrees is the same thing as 1 over the sine of 15 degrees. I just found the sine of 15 degrees, so all I need to do is find the reciprocal of that. So the cosecant of 15 degrees is just that fraction flipped over. And then the last one is even simpler. In order to find the cosine of 75 degrees, again, I could work this whole thing out if I wanted to as the cosine of 30 plus 45, and that would be fine. That would give me my answer. But there's an even simpler way to do it, and that would be to realize that because of my cofunction properties that we looked at before, the cosine of 75 is equivalent to the sine of 15 degrees. So that means my answer to this question I've actually already found, and it's going to be the exact same as the sine of 15 degrees.